Today we are going to discuss about the enzyme inhibition. Enzyme inhibition. Enzyme inhibition or enzyme inhibitors are the molecule that bind to the enzyme and decrease their catalytic activity. They stop the substrate from binding to the enzyme active site and hinders the enzyme from catalyzing its reaction. As we can see in this reaction, substrate can easily bind to the enzyme, forming enzyme substrate complex, and product is released. But in this figure, we can see inhibitor molecule has bind first with the substrate and it's blocked the active site. So now substrate cannot bind to this molecule and no product will be formed. Now inhibitor can bind either reversibly or irreversibly to an enzyme molecule. There are type of inhibition. One is reversible inhibition, irreversible inhibition and allosteric inhibition. Reversible inhibition can be categorized into further three types: uncompetitive, competitive and non-competitive. Irreversible inhibition, in which they react with enzyme and change it chemically. They modify the key amino acid residue needed for the enzyme activity, so product will never be formed and it will result into the dead-end complex. Allosteric inhibition, in which inhibitor molecules bind at the site other than the active site and decrease the catalytic activity of the enzyme substrate or enzymatic reactions. In this PPT or in this lecture, we are going to discuss about the reversible inhibition. What is reversible inhibition? Reversible inhibitors bind to the enzyme through weak non-covalent interaction such as ionic bond, hydrophobic interactions and hydrogen bond. So, they can be rapidly formed and can be easily removed because reversible inhibitor do not form any chemical bonds or reaction with the enzyme molecule. Now, different type of inhibitions are produced depending upon whether these inhibitors bind to the enzyme substrate complex or both. They are categorized into three types: competitive inhibition, non-competitive inhibition and uncompetitive inhibition. Now, let us start with the competitive inhibition. Competitive inhibition or we can say competitive inhibitor resemble the substrate and inhibit the reaction. Since they have the structural similarity, so they will compete for the same binding site on the enzyme molecule, that is active site. As we can see in this reaction, enzyme can bind with the substrate to form enzyme substrate complex, which will result in the product and enzyme will be regained. But if enzyme has bind to the substrate, it will form enzyme inhibition complex, which will result into the dead-end complex and no product will be formed. Since in this case enzyme and inhibitor are competing for the same site, so the effect of competitive inhibitor will depend upon the inhibitor concentration, substrate concentration and relative affinity of substrate and the inhibitor for the enzyme. If we increase the substrate concentration, there will be chances of substrate molecule to bind to the enzyme and chances of inhibitor molecule to bind will get reduced. And it will definitely depend upon the relative affinity of the enzyme and the inhibitor molecule. If enzyme has more affinity for the substrate molecule the chances of binding of substrate molecule will be high and inhibitor molecule will be low. So in this case, we can say that Vmax will be unaffected. That is, catalytic efficiency of the enzyme will not be disturbed, but Km will be increased because by increasing the substrate concentration, this competitive inhibition can be overcome. Example of competitive inhibitions are malonate. Malonate is the competitive inhibitor of the reaction catalyzed by succinate dehydrogenase. Malonate has the structure similarity with succinate. Next type of inhibition is uncompetitive inhibition. In uncompetitive inhibition, inhibitor molecule will only bind to the enzyme substrate complex and it will not bind to the free enzyme. As we can see that enzyme is first binding with the substrate, forming the enzyme substrate complex, and if inhibitor is not present, it will result into the product formation. But if inhibitor is present, it will form EIS complex, which will result into the dead-end complex and no product will be formed. Since this inhibitor is binding only when substrate has bind, it will not compete for the active site with the substrate. Maybe binding of substrate molecule will expose the binding site for the inhibitor and result in uncompetitive type of inhibition. In this case, both Vmax and Km will be decreased because by increasing the substrate concentration, this inhibition cannot be overcome. Same catalytic efficiency will get reduced. Example of this type of inhibition is alkaline phosphatase. It is inhibited by phenylalanine. Next is non-competitive inhibition. Non-competitive inhibition is when substrate molecule is Now let us start with the non-competitive inhibition. In this type of inhibition, whether substrate molecule has bound to the enzyme or not, inhibitor molecule can bind to the enzyme. That is, it can bind to the enzyme either in its free state or when it is combined with the enzyme substrate molecule. So in this reaction, we can see that enzyme molecule is binding in the substrate, resulting in enzyme substrate complex, and product will be formed. But inhibitor can bind to the enzyme resulting in EI complex, or inhibitor can bind to the enzyme substrate complex resulting in the EIS complex. Both will result in the Dedan complex and product will be not formed. In this case, catalytic efficiency of the enzyme will be decreased but Km will remain unchanged. As we can see by this graph, the example of this type of inhibition is AMP molecule act as a non-competitive inhibitor for the enzyme fructose bisphosphatase with respect to its substrate, that is fructose 1,6 bisphosphate. Thank you.